Now after second question, this is our third question to find partial differential equation. The question asks like find the differential equation of the set of all right circular cones whose axes coincide with z axis. Okay. Now they have not given us any equation. They have given us a cone, a right circular cone whose axis coincide with z axis. So here either you should know the equation of a right circular cone whose axis will be coincide with z axis, or let us derive it. This is our axis. Okay. X, Y, Z, X, Y, Z. One sec. Let me take this as Y, this as Z. Um, so axis coincide with Z axis, and okay, there we only this much. So let us take its vertex of the cone be at 0, comma 0, comma C. Okay, and this be the cone. Okay, now if you see properly, this particular circle, base of the cone, lies in XY plane. Okay, and we can say this is its radius, which is equal to R, right? This is R. So can we write equation of circle of the base of cone equal to x square plus y square equals to R square? Yes. Now if we take this angle as theta, okay, this is theta, then what can we say about tan theta? Tan theta is opposite upon adjacent, which is R upon adjacent is this particular height. This is equal to, if we say this particular point is Z, then this will be equal to Z minus C, this distance. We will subtract this C distance from total Z distance. So Z minus C, we will be left with this particular distance, this much. Okay. So can I write this as Z minus C? So R will be equal to Z minus C tan theta. Okay. If I substitute R here, I'll get as x square plus y square equal to Z minus C whole square tan square theta. Okay. This is the equation of right circular cone whose axis coincide with Z axis. Okay. Now we are tasked to find the differential equation, partial differential equation. So now the same procedure that we were adopting earlier, partial differentiate with respect to x and then with respect to y, and then let us see what do we get. Okay. So first partial differentiating with respect to x, we get as 2x equals to 2 into z minus c tan square theta into dou z by dou x. Okay, which gives us as x equal to z minus c tan square theta dou z by dou x. Let us say this is our 1. Now partially differentiating this again with respect to y, we get 2y equals to 2 into z minus c tan square theta into dou z by dou y. Okay, which is like y equals to 2, not 2, z minus c tan square theta dou z by dou y. Okay, this is our second equation. Now you know that we are tasked with eliminating this particular c. So equation 1 can be rewritten as, see, this is our equation 1. Okay. Here we can write z minus c equal to x upon tan square theta into dou z by dou x. Right? So we can write z minus c equals to, what was it? X upon tan square theta into dou z by dou x. Okay. This is our 3. Similarly, from here we can write z minus c equals to, I'll keep this color as red, equals to y upon tan square theta into dou z by dou y. Okay, this is 4. From 3 and 4 we see LHS is same. So RHS should be same. So equating RHS we get x by tan square theta dou z by dou x equals to y by tan square theta dou z by dou y. Here tan square theta gets cancelled out. So we are left with x into dou z by dou y equals to y into dou z by dou x, which again can be written as x y into dou z by dou x minus x into dou z by dou y equals to 0. This is the required differential equation, which can also be written as yp minus xq equals to 0. Okay, so yp minus xq equal to 0 is the differential equation of a right circular cone whose axis coincide with z axis. Okay, let's see you in the next video.